All right, we are going to be finishing up probability today. So go ahead and press pause and copy up to example 1, and then press play when you're ready. All right, so we are going to be doing predictions. So you can actually use probability to make some predictions on what could happen, okay, in the future. So probability can be used to make predictions for future occurrences by setting up and solving a proportion. So the actual probability, so the probability of you flipping a coin is 1 out of 2. You're taking that and setting it up with another ratio. So in other words, I'm going to give you a brand new total. So now I want to know, what's the probability of you getting heads if you flip the coin 100 times? So you use a proportion to set up and then cross multiply and divide. You first have to find the initial probability of me flipping a coin and getting heads, which is 1 out of 2. But then on the other ratio, it's going to be the whole amount is going to change to 100. So I'm giving you a brand new total. So let me show you how that works. So number 1, it says the probability of rolling a 6 on a number cube is 1 out of 6. If the number cube is rolled 50 times, then approximately how many times will the 6 be rolled? Okay, so on this one, they give me the probability of rolling a 6. It's 1 out of 6, so I didn't have to do too much thinking there. All right, because they wanted to get a 6, and we know the probability of getting a 6 is 1 out of 6. But now they want you to make a prediction on how many times I should get that number if I roll it 50 times. So this is how you work it out. You're going to write the initial probability first. Okay, so the probability of getting a 6 was 1 out of 6. Okay, but now I have a new total, and that new total is 50 times. Okay, 50 times. So we are looking for how many times I should get that number 6 out of 50 rolls. So that's how you set up your proportion. This is the probability of getting a 6. This is my new total. Okay, and the x will be on top. And if you remember how to solve these, we're going to cross multiply. So 1 times 50, and then divide that by 6. 48. I ran out of space, so I'm going to go ahead and put it here so you can see it. But 50 divided by, whoops, 50 divided by 50 divided by 6 is 8.3. Okay, so it's pretty much going to be 8 and a third. So 8.3 repeated. So I can guess 8.3. I'm just going to round to 8. So I can predict that I will get it 8 times. Okay, so we're rounding these to the nearest whole number because I can't get the number 8.3 times, but I can get it 8 times. All right, so I can predict that if I roll it 50 times, 8 of those 50 times, I should get the number 6. Okay, so that's what you're doing. It's just proportions. The first ratio is your initial, sorry about that, is your initial probability. So go ahead and copy number 2A down and our 2 down. We'll pop number 2 down and give yourself room here because we're going to work here. And then press play when you're ready. Okay, so Albert surveyed a random group of 7th graders as to whether they preferred video games, sports, or neither. We're going to use the survey results to make predictions for the entire 7th grade class with 300 students. So they gave us some information here. We have video games, sports, and neither. And we have 300 classes. All right. So in letter A, it says, what is a reasonable prediction for the total number of 7th graders that prefer video games? So I'm going to look at the video games first. I first have to figure out the initial probability of video games in the table. So I have to add these up first. So 15, 22, and 3. Let's add them up. So I have 40 total in that table. So that's where I'm going to get my first probability from, okay? So the probability of getting a video game. From the table, I have 15 students who chose video games out of a total of 40 students. Now that came from the table, okay? Now, if you want to simplify this, which I really would before I get into the proportion part with the 300 students, I would definitely do that. So I'm going to go ahead and simplify this by 5. And that'll give you 3, 8. So the probability of getting video games from the table is 3 out of 8. But now I have a new total. So this is our new total. So the new total is 300. So we're going to take the 3 out of 8. So there's my 3 out of 8. Okay, this is the probability of video games. And my new total is 300. Because this is definitely does not represent 300 kids. It only represents the 40. So we have to use a proportion. Go ahead and cross multiply. 3 times 300 is 900. Divided by 8, that's 1. 1. And let me see. 112.5. So we can guess, or we can make an assumption that we should have 113, because that 0.5 is going to make me go up 1. 113 students will prefer video games. Okay, let me just make sure the math is right. 900 divided by 8. Yep, 112.5. So because of that 0.5, let's round up to 113. So we can make a prediction that if I surveyed 300 students, about 113 should like video games, okay? And these are just predictions. We're just making a prediction, an educated prediction, okay? And we're rounding to the nearest whole number, round to the nearest whole number. And I'll make sure I put that in the assignment as well. Okay, go ahead and write letter B down. And we're using the same table, okay? But give yourself some room there. And press play when you're ready. Sorry. Letter B. What is a reasonable prediction for the total number of 7th graders that prefer neither? So I want the probability of neither. So neither is going to be 3 out of 40. Okay, that is the probability of neither. I have 3 out of 40. Okay, that's just basic probability. And then now I want to know, okay, well, how many will choose neither out of the 300 students I have? That's all you have to do. Now it's up to you to cross multiply and divide. So I'm going to go ahead and cross multiply here. 3 times 300, 900 divided by 40. You could cancel out the zeros if you want to. Is that 2 again? That's 80. 22.5. So we're going to round, okay, because you can't have 22 and a half of a person. So I'm going to say 23 students are going to pick or should pick neither. Again, it's just a prediction, okay? So 3 out of 40 chose neither in the table that they surveyed. And now if I were to survey 30, I can predict that 23 will choose neither, okay? And go ahead and copy C down. Based on the table, what is the most reasonable prediction of the number of votes for sports in the next 80 votes? Okay, so now I'm not even looking at 300. So now I'm doing sports in 80 votes. Okay, so the sports, we're going to take a look at our table again. Sports is 22 out of 40. 22 out of 40. Okay, because in the table, 22 students chose sports out of a total of 40 students. But now I want 80 students. There's my new total. Okay, so my new total is 80. And we're going to predict how many are going to choose that. So let's go ahead and cross multiply. And you could have simplified 22 and 40. It's perfectly fine. So 80 times 22 gives you 1,760. Okay. And we're going to divide that by the 40. Divided by 40 will give you 44. That came out perfect. Okay. So we can predict that 44 students out of 80 will choose sports as their favorite. Okay, so once again, to solve these, set up the initial probability, then use a proportion to solve. Okay, let's see. I'm going to give you two scenarios to try out. So press pause to try them out, and then press play when you're ready. All right. Number one, a box of 25 light bulbs is shipped to a hardware store. When it arrives, 4 of the bulbs are broken. Predict the number of broken light bulbs of an order of 125. Okay, so you should have found the probability of broken bulbs. And that is 4 of the bulbs are broken out of a total of 25. Okay, 4 out of 25 are broken. That is my initial probability. But now we're changing it. My new total is 125. Well, if 4 of the 25 are broken, how many are broken out of 125? So if you saw the shortcut, you probably did the shortcut. If not, that's okay. You're just going to cross multiply 125 times 4. It gives you 500, see? Divided by 25 gives you 20 broken bulbs. Okay, so you should have gotten a prediction of 20 broken bulbs. Now be careful because sometimes they'll tell you predict the number of bulbs that are not broken. Okay, so there you'll have to do a little extra thinking. But you could have just done this and then subtract 20 from 125, and that would have given you the ones that are not broken. So 20 of them are broken, 105 are not broken. Okay, so let's see how you did number 2. On a subway, let me highlight. On a subway, 6 of the 11 people are carrying a briefcase. So 6 of 11 are carrying a briefcase. Okay. Based on this information, if there are 800 people on the subway, then about how many do not have a briefcase? Ooh, okay. So 6 of the 11 people are carrying a briefcase. But they want to know the ones who are not having a briefcase. So you have to think about here. I have 11 total people. 6 are carrying a briefcase. How do you figure out the ones who did not carry a briefcase? Should have subtracted. So I have 11 total minus the 6 with briefcase. Okay. Forgot the C. Which will give you 5 without briefcase. This is the total. That way you know where I'm getting my numbers from. Okay. So you should have gotten 5. So the probability of no briefcase is 5 out of 11. Okay, 5 out of 11. Then I want to take that and figure out, okay, if I have 800 people, how many can I predict will not have a briefcase? So that's the initial setup. And you would have done 5 times 800 4,000 divided by 11. 363.6, which let's round it up to 364 without briefcase. Okay. Now, if you didn't get 364, I bet you got, let me see, 364, I bet you got 436. If you got 436, that means you gave me, or you predicted the amount of passengers that would have a briefcase. But I want the ones that do not have a briefcase. So once you had the 436, you could have just subtracted that from 800 and you would get 364. So probability is okay, but you have to be sure you read the directions because they are kind of tricky sometimes because of those knots, right? Now, if you have any questions, always come to the Google Meet and I can help you with your assignment. All right. I will see you tomorrow, guys. Have a great day. Bye.